lead us through the third video in the walkthroughs. So over to you, Srinivas.
Okay, good morning, everyone. So I'll get started here and share the screen. So can everybody see my screen now?
Yes.
Okay, so I'll get started here. I'm sticking with the O3 data core, excuse me, in order to just go through a few items that Jeremy covers in the beginning. These aren't material to what the major substance of his video is, which is data loaders, plural, and data loader, singular. The two classes of FastAI data loaders that he takes us through the code. But I just thought it would be good to just show things that he mentions in the beginning of the video which aren't current. For example, there is no longer a CUDA transform, which he talks about, but there's still pieces of the code that are relevant. So I just highlight it here. I won't bore you with the details, but if you can go through the code of ToDevice, which is used to move stuff that you have or code from one device to the other, for example, from the CPU to the GPU or vice versa. And there's the actual code for what the function does. And as you can see, it recursively puts whatever B is on the device. And it uses this underscore inner function in order to do that recursively. The other detail which he points out is he uses apply, and there's a fast AI version of apply as opposed to the PyTorch version of apply. And this is subtle, but he does that many times, and you'll see, in fact, that he is, as we go through the rest of the video, that Jeremy has completely or mostly rewritten the PyTorch data loader to become different and enhanced FastAI data loaders. So similarly, has rewritten the apply function as well, which we'll see in a minute. But before that, it's also the other command which is still relevant from the few things he mentions at the beginning is default device. And as with many things Jeremy does, it kind of took me a while to understand what he was doing, even though I know all the detail, but sometimes when you look at it out of context, you lose what the meaning of it is. For example, here he says default device use CUDA equals -1. And while I'm familiar with Python and I've kind of used it quite often, I forgot that all he meant to do there is say that use CUDA is false. That's why he just says use CUDA is -1. And took me a while to figure out that that's what he was doing by specifying use CUDA as -1. So anyway, the default device.
Why do you think he did that instead of just saying use CUDA equals false so that everybody would understand what he meant?
I think this is his thing between brevity and kind of, the exposition of what it means, clarity, if you will.
Yes.
I think he often, and in many instances, rightfully, I think leans on brevity because the code captures everything within a page or everything within a screen. And I've often found that that is relevant. Like, one example where I think it is really helpful is he defines, we saw that in when QB took us through like set attribute, set attra that he uses, a custom function, where instead of doing self dot something, self dot x, self dot y equals, or self dot x equals x, self dot y equals y, he just is set attribute and a whole bunch of strings all in one line. So he leans towards brevity, tends to do that. And so, but sometimes it throws me for a loop, because until I figure out what he's doing, it just frustrates me. And this is an example. That's why I thought I would highlight it, because it took me a while to I was like, why is it use CUDA -1? Does that -1 value mean anything?
Yeah.
And then it finally dawned on me that all he
Well,
was doing was.
yeah. See, that's what bothers me something. I mean, I'm just ranting a little bit, but that's what bothers me something about Jeremy's attitude. He saved 6 characters because he used -1 twice in place of false. And but it takes people 15 minutes to catch on to it. So it's not worth it to me. I mean, to me, brevity is something you should be very careful with when you trade it off with understandability. But anyway, and I don't think he makes that choice in a way that pleases me. But that's just my opinion. Anyway, go ahead.
Yeah, no,
the library is opinionated. He's opinionated to his own standard. So like he writes it for himself, kind of makes it easier for him. So yeah.
Well, that's the thing. I mean, he really is writing it for the community. He's a very community-minded person, and he's doing this not just for himself, but this is what. But when he writes this code in this individualistic way, it's hurting him actually if he wants to communicate. And if he wants to really make people understand, he should be a little more careful with trading off brevity for clarity. But anyway, that's just my opinion.
Yeah, so I mean, I highlighted it for that, to point out that sometimes it's a trade-off, and I agree with you. It took me a while to figure it out, which is the reason that I'm highlighting it, that, I was like, there must be some meaning to use CUDA as -1, and I was hunting up, down, sideways until I realized, oh, geez, this is what he's doing. Okay. So anyway, this default device is just, you can figure out what the device is. For example, I'm running on a desktop. It doesn't have or has an old graphic processor. My device is just CPU. Another thing which he does often, and you need to be aware of it and conscious of it, because I've gone searching, I think, and Rekil put me straight once. For example, I forget whether it was something regarding dot tensors and stuff, and he pointed out something in PyTorch, and then I figured out, oh, that means Jeremy isn't using the PyTorch version as is, he's doing something to it, and it turns out he was. Similarly, here, there's an apply in PyTorch, but he calls out that there is a FastAI apply, which I've called out here. I just create these my own versions of this notebook, so I don't have to go searching, and I just query it and stick the entire function inside inside a cell, so I can see it right there. And what this apply function does is, as he has said before, it recursively applies the inner function, which we saw. The difference between his version, that is the FastAI version of apply, as opposed to the PyTorch version of apply, is that the FastAI version keeps all the types consistent everywhere. So you can see that it does that by using this type of X and then applying the function over the O, and with all the args and keyword args for O in X. And that in turn ensures that, and he uses, for example, this retain type, which we'll get into and understand the details of later in the lecture, but retain type helps to retain the types of what is in result, for example, or what the function returns. And so in this case, it maintains the subclasses as is. That's point one, where it is different from the PyTorch version. And secondly, instead of changing something, meaning instead of just doing it in place, it actually returns it. So I haven't gone and looked at the PyTorch apply, but I would assume that PyTorch apply just applies the function to the value and therefore changes the value. Here, as he says, there's a return here, and therefore the FastAI version of apply, rather than changing something, it returns the result of applying the function. So those are the two differences that you need to be aware of as he uses it. So sometimes this can lead to confusion because if you're familiar with PyTorch and you apply and then you think it would do it in place, it doesn't, and it returns, which could be a surprise. Vice versa, if you're used to FastAI apply and you think it's returning, PyTorch would do it in place, and that could confuse you too. So good to be aware of these differences as you use FastAI. Then he kind of shows the example. Here's another thing to rant about, Joseph, if you are so inclined, because you'll see this contribute to what his style of coding, if you will. He uses this @docs decorator. And what the decorator does is take all the doc strings, which he shoves into one dictionary at the very end, and then distributes it to the appropriate locations in the class. In turn, it uses the @docs function. So an example of this is, let's go down and look at data loaders, for example. And as you can see, there is an @docs decorator at the top. And what it does, and you'll see that he has no documentation whatsoever other than for the data loaders class itself, plural. And the @docs decorator, what it does, it grabs the values from the _docs dict and sticks them underneath the relevant methods, if you will. So he puts all of the documents here. So for example, train. So you'll see when, and we'll get to how he does that later on. But for train, it'll have that documentation. Take an easier example, CUDA. So use the GPU if available, it goes under CUDA. And one of the reasons he writes also, this is something, again, he writes it in a single line, is so that you can stare at this and have all of the code show up on a single screen. And it doesn't have the documentation right here. For example, the more traditional style would be def CUDA, underneath the self, you put the documentation, single line, and then return. So that causes CUDA to expand to 3 lines, CPU to expand to 3 lines. Instead, he uses the @docs decorator on top and then sticks all the documentation in a dict, and it goes to the relevant part when you use the decorator. So that's something else he kind of expands on in the beginning of the class or the beginning of the lecture. Then he talks, the next thing he talks about, which is again a customization of what already exists in Python. And you'll see as we begin to go into especially this section and then going through next several lectures that it's as much about learning software engineering and Python coding, which I'm not an expert at. So I love that he does this and really makes me a better coder, if you will. He customizes a lot of Python functions and shows right now, at least in the beginning, say, for example, in video 3, 4, 5, 6, we'll go through mostly how they are used, or sorry, what they do. But towards the end, in lectures 9 and 10 of this whole walkthrough, he takes us through each of these. For example, what does get itra, what is the code, and how the code does what it does. So today, we'll just stick with what it does and how it helps with respect to the data loaders. So there is a dunder get itra function. Maybe many people who are better coders than I am are already familiar, but essentially what dunder get itra does is if you do not have an attribute in your class, if there is a missing attribute in a class, then if you specify a dunder get itra, then it'll default to that and it'll do what the code you provide in dunder get itra. But there are a couple of issues with that. The first issue is it doesn't tab complete, which is something that Jeremy hates. And rightfully so, because it doesn't, tab completion helps when you're coding immensely, and that not having that available is a pain. So he wants to fix that. The second issue that he talks about is the traditional decorator in Python defaults all of the attributes that are missing to decorator. And he wants some control of that. And that control is provided by the getAttr function. And we'll see that essentially what his code does is specify yet another attribute called, there are two attributes which he uses in his version of getAttr. One is this default attribute, and another you'll see that used is extra, or sorry, single underscore extra, which limits the attributes from your class that are then passed on to the default. So we'll get into the details of how an example of that. So if this is all abstract, and for a little bit, and we'll get into the details, but that's what inheriting from his version of getAttr, not the Python version of getAttr, does. So that's the getAttr. And as I mentioned, we'll get into the details much later of this particular code and what are all the things he needs to do and how he does them in order to make sure that the getAttr you see here is redefined with all the attributes that Jeremy really wants to have.
So, Srinivas, what was it? Oh, go ahead, John.
I'm very surprised to see a class which doesn't have an init method. Why would you have that? Does anyone know why you'd create something like that?
John, it's not always the case that you would need init method. Many classes, if you're just inheriting from something and you're already using and you're not changing the init, don't necessarily need to have init method. So there are examples, and if I can find any simple ones, I'll post them on Slack later. But while init is definitely very commonly seen when you define a class, it's not a must. And in fact, I think around lecture 5 or 6, you'll see something happen before even a init happens. So there are many things about the class that you'll get more detailed understanding of as we go through the rest of the walkthroughs.
Okay, I shall stay content to wait till further weeks. Okay, thank you.
Srinivas, you said something about completion, and Jeremy hates it, and I kind of missed that.
Sure, I'll unfortunately, here is the problem, and this is something that I'm frustrated with. I've actually complained to Colab guys, but because of one person, I don't think they're going to change it. Mm-hmm. One of the things, so what I was talking about or referring to specifically is tab completion.
So tab completion, okay.
So this is the same thing where inside of a function, like if you're specifying a function here and like data loaders or data class, just do data loaders. And if you, here, I think what Colab does is if I hold it on top, it gives me, what is inside of data loader, the options, these things. But for example, you can go inside the brackets and shift tab, and it'll give you the, what can be filled there. That's the traditional Jupyter Notebook way of finding out what's in, what are all the options you can provide to the data loader class. And unfortunately, Colab doesn't support shift tab, and you have to go configure it. I tried configuring it by turning off certain things, but bottom line, Colab doesn't support all Jupyter Lab options. And so I can't illustrate the shift tab other than to show you by hovering over it like this. But typically in Jupyter Lab, if you're using it outside of Colab, you
Dot
can
should
actually
work,
do.
Srinivas.
Sorry.
If you just do data loader dot.
Yeah, that still works. Yes, but that will give you the options. But Jeremy's tab completion is specifically, he's talking about doing a shift tab within, and that doesn't work in Colab. But as Rekil pointed out, the dot works, hovering over data loader works.
Yeah, I usually do it by putting a comma, like add a comma, then delete it, then it pops up. Like
Sorry?
inside the brackets, like I usually like add a comma, then delete it, and just put a comma, then backspace, it pop up, and that's how I usually do.
Yeah, that's another way of getting it. But you can also hover over it if you in Colab, and it gives you that.
Yeah.
So don't even need to, because programmers are lazy, and I'm learning to be that way. So typing a comma and backspace is 2 more things I have to do than just hover.
Yeah, true.
So anyway, that's what I meant, Joseph, of shift tab completion. And he goes to quite some trouble. We've also, I think QB took us to add delegates, which allows you to know what's tab completion when you use keyword arguments, which is again a problem, because if you just say ** keyword args and you're inheriting from another class, you don't know what the keywords arguments are for that class. And Jeremy again prevents that by, or helps avoid that, and makes, in this case, really helps with clarity by using the add delegates decorator. He has a whole blog post about it that you can go read. Anyway, getting back to getAttr, so that's why he inherits from getAttr and data loaders. And we will understand and explain, I'll explain more in detail, but what I will highlight to you, because that is important to understand, is the default attribute, which is what Dunder getAttr and his getAttr delegate to. In the case of data loaders, the default is train. So if you do not specify an attribute after data loaders, and we'll see its usage, and when you see its usage, it'll become clear, but I'll just mention it right now. If you miss or you don't specify a train, it defaults to the train attribute. That's essentially what the underscore default equal train, and then inheriting from get attribute within the data loaders class does for us. And we'll see its use a little just in the very next few cells. So again, typical Jeremy style, he first talks about data loaders, which is just a bunch of data loaders. So it's essentially a wrapper around multiple data loaders. And then we'll spend the rest of the class looking, or I keep saying class, but the rest of the video lecture looking at the details of the single data loader. And that's quite involved and complicated code that he takes us through very in a lot of detail. So we won't spend a lot of time looking at this code, but we'll understand better, I think, if we just look at the usage of the data loaders. And I think I saw somewhere earlier that Anant had a question of, hey, what happened, or where did data bunch go? And actually, if you listen to the video, and this is one of the changes that have taken place in the code, even in the video, it talks about data bunch, but there is no data bunch in FastAI version 2. Essentially, that's been replaced by data loaders, which is just a basic wrapper around multiple data loaders. So key difference, no data bunch, just data loaders. Okay, so the reason I stuck with using this particular notebook is he uses the previously defined transform data loader that we had already defined. And I just wanted to highlight what we had in the transform data loader earlier. It's just 0 to 49 range of integers in that data loader. That's what we have currently in there. And so you can execute that part. I think I may not have executed this, which we do. And that's just previously defined in the code. You can look it up. So the B is just one batch. And after the batch has been created, he applies the neg transform. And that is defined previously as well. And let me just show you that. The neg transform is defined to be just the negative of the batch, but this is where he has applied TFM, and then TDL is start. Start is just a range from 0 to 49. And after a batch has been formed, and a batch is batch size of 4, and after the batch has been formed, you apply the negative transform. Therefore, you can see that a batch is just 4 values negated from the transformed or negated from the start values. So that's essentially what you see. So far, no use of data loaders. This is just the transform data loader that I think Joseph and Dr. V took us through. So that results in this tensor. Now, first of X is again just a function he uses to return the next value of X. X is converted into an iterator, and then the next value of that is taken. That's what first of X does. So you can think of first of X as just running the one batch at the beginning, at the very beginning. So using the data loaders code that we saw before, you give it 2 transform data loaders. Remember, data loaders is just a wrapper around multiple loaders. So it wraps around these 2 data loaders. In our case, or for the example, you just use the same transform data loader. And here he then goes on to find what is X. X is the data loaders train attribute, or the value of train data loader within data loaders, and then a single batch of the train data loader from within the data loaders wrapper. So that's X. Then you define X2 to be the first of the transform data loader, just a single data loader. And recall that first just does the next iter of X. So it will return the first batch from X, which is TDL. Now, this is where what we discussed before is the fact that the very first data loader gives you the X2 value, and then from the same data loader is extracted the train and the single batch. So you expect X and X2 to be equal, which is what he's testing by saying test equal X and X2. And then here is where he uses the getItera function that I talked about earlier. You'll notice that X, he's defined X as, let me just execute this code. He's defined X as DLS, which is the data loaders, train attribute, and one batch. And if you see here, he has dropped train, and he just says DLS.one batch. And as I say in the comments, because of the fact that your data loaders inherit from getItera, which means that, as I explained before, any attribute that's missing is delegated to whatever is with the string which is within under default. So that points to train. So what that means is, if in this case I do not say train and I just say DLS.one batch, it knows to go get the one batch from DLS.train.one batch. And this keeps it simple and also lets us write, if you will, shorter code, which basically you don't have to keep specifying that DLS.train.one batch is what you meant. it understands that dls.train.oneBatch is what you meant when you say dls.oneBatch. And that's why you see that when he tests for equality, x and x2, then they turn out to be equal. Any questions about this particular aspect?
Sorry, what's the train again? Is
Train,
this the...
Yeah, we'll just get, in fact, the very next thing we'll get into a little more detail, but train is just the first data loader that gets created within these data loaders, right? So a train, you'll see train and valid are added as properties of this data loader. And train dataset and valid dataset are added as properties. And I'll explain what the add properties function does. But train basically is a method or is an attribute of the data loader function, which refers to the first instance, that is at index 0, whatever the data loader is that's been created. And that is typically the training data loader that we want is the very first data loader, and the valid data loader, which would, so for example, again, keep in mind that all these data loaders, what they are doing is trying to get your data, create the batches, and provide them as input to whatever algorithm you're using. So typically you would expect to have, or expect the training data loader to give you two results. One is your image. Let's say we are doing classification to keep things simple. The first of the tuple that it will give you is the image. The next will be the label. And the training data loader will have both of them and will give them to you. Then the valid data loader will also have a number of tuples created through batches. And in each batch, it will yield a tuple. Typically, again, all I'm saying is typical, there are exceptions, and I'm using the classification example. It will give you a tuple, which will, the validation data loader will also give you a tuple, which will be a image and a label. So when you get data loaders, which is a wrapper around multiple data loaders, in this case, he has made both the training and the valid data loaders the same. That's why he is supplied TDL twice, as you can see here. Typically, you would make the first one what you would want to be the training data loader, and the second one what you would want to be in the validation data loader. Here, since he's explaining the concept of data loaders, he doesn't want to confuse that. He just gives both the same value.
Okay, so in a sense, when we don't mention anything like DLS.oneBatch, it's given that the data is coming from a trained data loader. Yes. But if you want to fetch the data from valid, then we do need to do
DLS.valid.oneBatch. Yes.
Okay.
Yes. Correct.
OneBatch also is like a FastAI thing and not PyTorch. That's one more thing to kind of point out.
Yes, OneBatch is, in fact, OneBatch or Fast. OneBatch, I think we'll see, I forget where it's buried. It's likely buried in data loader or even in a data set.
And data loaders, yeah.
Yeah. And in fact, sorry, just one more thing to mention. First is also a variant of the same, except OneBatch is generic. It just grabs one batch wherever, but first is it'll just do the next iteration of wherever you are at. So that's also, the first is also a FastAI thing, FastAI function, if you want.
Okay.
Okay, so yet again, another brevity modification by Jeremy. Instead of saying, so if you see in the data loader code, instead he has these two lines, train, and then just for alignment. And in order to keep things simple, I use the train DS and valid DS example. Instead of 2 lines of code or 4 lines of code where it says train DS is, or just like the property here, where he has used the add property decorator and then define the device is return self.device. He does this thing where he says, I'm going to add train DS and valid DS as properties of the data loaders class using this Lambda function and put it all in a single line. And what does add props do? Well, it's yet another convenient function that Jeremy creates. And it has three variables that you pass in. Typically, in this case, he uses n is equal to 2. And what add props does is creates properties passing each of range of n to f. So that means it's going to create a 0 and a 1 because it's range of n and n is 2. So it's going to create 0 and 1 property. And as I said, for simplicity, assume the second thing passed is none. So if g is none, then it just makes a property of the partial function of f of I for I in the range of n, which means it'll create f of 0 and f of 1. That means what you have happen is that here, train DS becomes the property using lambda I x of I, and I will first be 0. So x0.dataset will become train DS, and x1.dataset will become valid DS. So at the risk of screwing this up, I'll try and illustrate what the def property does. So instead of doing add property def train DS equals lambda x x or actually I should say you don't need I and x if you do it this way. And then do the same thing again for.
Don't need a lambda there, right, Srinivas?
Oh yeah, you don't need it because you're not passing up. Yep, right. It's just that, right?
Yeah, you want to return though. So you just want to do return x of 0.dataset. Right?
That's a function.
Passing x.
0.dataset, right? No, at train is equal. There is not even a.
There should be an equal, right?
No,
right.
It's not. Oh.
But you can see def train return self x dot 0. So actually you have to do it this way at train ds and self.
Yeah, right.
Right. And then just colon return x.
Self.
I think that should be
Self, not x 0, self 0.
Right.
Yeah.
That's why I shouldn't like code. Self 0.dataset. Okay, and then you would do valid DS. Self return self 1.dataset. So again, and to be traditional, you do this and you do that. So this is what you would do if you wanted to replace this single line that he uses, okay, or I should say this single line that he uses. So that's what add props does, is it takes this index, creates two properties, takes in self as X, takes 0 and 1 as I, and sticks those properties and returns them into train DS and valid DS. So you can see that all of this he does in a single line by defining a function called add props. So there is, again, Jeremy's brevity, but in this case, I think it really helps because it removes all that code and you just can simply understand, as long as you know what add props does, which I've given you the code down here, you can quickly understand that all it's doing is creating two properties, one called train DS, another called valid DS, and each of them refers to the self0 data set. So it's the training data set and the validation data set. And the train and valid are the training data loader and the validation data loader. But in this case, he uses the G, which is the second value or the second function that he passes in, if you see below in definition of add props. Any questions?
Just no question. What's the difference between the data loader and a data set? What else we have in a data loader other than a data set?
Excellent question. In fact, it's almost like I paid you to be my setup person for the rest of the lecture, because in the rest of the lecture, he'll go into great detail of what a data loader is, how the FastAI data loader is different from the PyTorch data loader, and what are all the enhancements and changes he has made in order to be able to customize every single piece of a data loader and for you to be able to inject what you want the data loader to do. So,
sorry, quick question and follow up on that. Wouldn't a data set talk about the data and the transformation that you do to the data? In the data loading, is adding a layer on top of the data set that would allow you to think about batches. So wouldn't be the difference in between a data set and a data loader, that the data loader talks about how do I create batches for the GPU, and the data set does not have that information?
yes, that's correct. But that's just one of the many things that a data loader does. And so what Kibi is rightly pointing out is that a data loader gives you the concept of batches. A data set, and just this again is defined explicitly as I start into the next part of the lecture, but a data set, as she correctly pointed out, is just a bunch of things that are collected together. And in case, if you want to define it in terms of FastAI, a data set is anything that has a collection and a get item or a length, basically. It has a bunch of items and it has a way to get them out. So it has a dunder length value. So it's a collection and you can get every element of the data set out. But a data loader, again, as PB pointed out, is the fact that you can batch it and you can batch the data set items and get them out as batches. But that's just the first part. You'll see in the rest of the entire lecture how much more complicated, and it's not complicated just because it wants to be, how much more flexible and customizable at every stage that Jeremy makes the FastAI data loader compared to the PyTorch data loader. But at root, PB is absolutely right. The data set is nothing but just a collection of items with an index or an iterator that you can go through them. But data loader gives you the ability to batch the dataset items and much more than that, as we'll figure out soon. So anyway, I think those are all the things I wanted to cover. The rest are just methods that he points out. And then we'll later on, again, return to the transform data list And I think we went over the data sets initially of this particular notebook. So I'm going to stop sharing for a minute while I pull up the data loader class, which will take us through the details. Again, remember that what we just went through in a top-down fashion is data loaders, which is just a wrapper around multiple data loaders. And we just saw a usage in a very simple case of what we can do just to test the value, but we'll see much more. The data loaders themselves are wrapper around a single data loader, which we'll get to next in a minute. So I'll stop sharing as I switch notebooks. Okay, can you folks see my O2 data load notebook?
Yeah, yeah.
Okay, thanks. So I'll go to the relevant part here. The thing I wanted to point out in the beginning is he uses this particular example throughout the initial part of the lecture. So he defines the batch size of 4 and defines a data set, if you will. As QB was pointing out, he uses a data set of letters, which is just a list of the string of all lowercase ASCII letters, so A to Z, okay? So that's what he's going to use as an example of when he illustrates the details of a data loader. Okay, so we'll jump through this, we'll come to this later, but here is where we'll start looking at the data loader class. And here we are really getting into kind of the nuts and bolts of the library. So they sometimes it's going to be much more of Python, but it is interesting as to how he customizes. A few background things, as I mentioned a couple of times already, he's replacing the PyTorch data loader with a FastAI data loader. Why? And as he talks about in the video, multiple reasons. Predominant among them, Jeremy wants to customize the data loader to be able to do different things at different parts. He wants to use callbacks in order to customize what the function does. For those of you who have listened to version 3, part 2 of his course, he takes us through how he customizes the, if you will, the training function, so that at every step of the training function, he has callbacks. What are callbacks and what do they do? I provided some links in the references that for this particular video or in prior videos, and I'd encourage you to look at what they mean, and also encourage you to look at the version 3 part 2 of the course in order to understand the extensive use of callbacks in the training part of, in the actual training and optimization loop. Here, what we'll see is in the rest of this lecture, we'll see the extensive use of callbacks which allows for customization during the data loading part of FastAI. So he wants to do all that customization, and he can't do that with just a PyTorch data loader. So that, I think, is the biggest reason he wants to change it. The other reason he wants to change it is, and he's only partially successful with this goal, as we will see in the rest of this lecture, but the second reason he wants to do it is he really says that he dislikes the code of the PyTorch data loader because it's kind of intertwined, too many dependencies which are all intertwined. It's not clearly separated, and that makes it hard to do the things that he would like to do, which is basically customize. However, what he does realize is the fact that PyTorch data loader, as it says here on the comment, is really founded on a very fast and very thoroughly tested multiprocessing system. And that's multiprocessing code or multi-threaded code. I'm sure some of you have already written it. I have not, but I've done the hardware side of it a lot more, and it's hard to get programs running in multi-code or multi-processing systems and get them to execute correctly and fast. And PyTorch has done that successfully with the data loader, with their data loader. So what he does is he pulls out from PyTorch code the code that has to do with the multiprocessing piece, which is in this multiprocessing data loader iter, and he just uses it as is. But because he's now using some portions of the PyTorch data loader while customizing a lot more that he doesn't use, the interaction between the FastAI data loader and the PyTorch data loader still exist. And that's a little bit of, what I would term gnarly code. He terms it something else. It's ugly code. The ugly code, however, he restricts it to a particular class, so we don't have to deal with it in multiple places. And we'll see how he uses that particular class in order to continue to use the foundation, the multiprocessing foundations of PyTorch data loader. So if you see up here, you can see that he just uses the loaders from Torch, especially the multiprocessing data loader as is, and the single process data loader iter as is. He doesn't change that. He just says that's underscore loaders, and I'm going to use this as is. But then, and we'll get into it much more in detail, so I'm going to skip other than to mention, this is the portion where the ugly code resides, which allows him to back into using the PyTorch multiprocessing data loader. And how he does that to a first order, again, I don't know or can't explain every nuance, but how he uses it by and large, we'll get into as we go through the code for the data loader. But
Srinivasa, a much simpler question. When you're looking at data loaders, you're getting data from your training set and your validation set and so on. What kind of flexibility do you want there that is not currently available?
Sure, and he'll, I think, I swear that you and I haven't talked before to set this up, but that's again a very perfect question for what we'll get into in just a few minutes of how and why the customization is needed. But I'll answer your question shortly here, and then we'll get into much more detail. As I think QB pointed out, to give a credit, it's like, you get the data from a data set, right? Like, for example, from the letters list that we will be passing into the data loader. And in the very next example that I'll get into, you can see that you can do things after you have created an item. You can do things. When I say do things, what I mean is you can tell the FastAI data loader to do certain things after it has created an item, before it has created a batch, after it has created a batch, before it starts any iteration at all of creating these loaders, after it has completed all of the iterations of providing the batches. those kinds of capabilities of telling the data loader to do things at any one of those different points is not inherently available with the PyTorch data loader. And those are capabilities that the FastAI data loader provides you that a generic PyTorch data loader doesn't. So it's using all these callbacks before item, after item, before iter, after iter, and we'll get into examples of the flexibility of and why, or what kinds of flexibility it provides in just the very next several minutes. Does that answer the question though at a high level?
It does. Thank you. It just helps to provide a bit of context.
Context, yes. So, what again, we'll go through many portions in detail of this data loader class. And as you can see, it also inherits from getAttr. So it will use the default attribute. In this case, the default is dataset. So that means if you say, for example, a data loader dot, and you don't give it anything and you directly go to using some of the attributes, it knows that it to apply it to dataset. So it's dataset here is equivalent to train in case of data loaders that we saw earlier. So let's jump to an example, because the best way to understand what data loader does is to use example. Okay, let's see whether this is, okay, this is not, this one is. Okay, so let's look at what he does with providing a batch. Remember that the data set in this case that he has provided is the list of all ASCII letters from A to Z. So that's the data set that we have with us. So now we create a data loader, provided the data set, which is, remember there are 26 items in here. We provided a batch size of 4. We say drop last equals true, and then the number of workers is 0. Now he defines this function 2 epochs, and I'll just quickly explain, but you can play with it to understand what it actually does. It essentially combines each batch without any spaces. So for example, A, B, C, D, remember batch size is 4. So out of the 26 letters, each batch you will get is 4 letters. It combines that. And then after every batch, it introduces a space and sticks them together as well. So you get, that's why you have these 2 joins, and it does it in the range of 2. So it does it for 2 epochs. So goes through A through Z once, and then A through Z, the letters again. And you can see that it has a drop last equals true, which essentially says that you drop the very last 2 letters of the entire list from A to Z. So you can see that YZ, which will only be 2 letters, is dropped because it isn't the same size as the batch size of 4 in everything else. So all the other batches are 4, and these 2 batches are, the last batch is just size 2, so it drops it, which is what is specified by drop last equals true. So the test equals, what it tests is when you do 2 epochs and supply the data loader, what you would get as an output is 2 epochs of going through all of the letters, each batch yielding us 4 values of the letters, which is A, B, C, D, and then joined by the space, E, F, G, H, and so on until, sorry, I'm at the wrong one, until it gets to X, drops the YZ, and then does the second epoch again. So that's what the DS1 is data loader, and then test equal 2 epochs DS1 does. So by creating this data loader, we have actually created the ability to provide the batches and then go through it 2 epochs while dropping the last batch, which is not of the same size. You can do the same thing and not specify the drop last which means you can see that the values YZ are included. Similarly, you can, instead of using letters, you can provide it a range of 12, which means it's from 0 to 12, 0 to 11. And what it does, just like the Python data loader, the FastAI data loader also, and it has code up above that we'll see which does it, but it converts numbers and ints into tensors. So you can see that the data loader range 12, when he has to check it, and I think QB took us through an example of this, if I recall correctly, it's the test equal type, what it does as opposed to test equal. And we'll again see the details of this function in the very last two walkthroughs. Not only does it test the equality of the values, that is L of DS1 and L of this, but it also tests that the type of DS1, what DS1 returns, and what L of this returns is the same. So what it's actually testing is not just the value 0, 1, 2, 3, but it's also checking that the value returned is actually a tensor 0, 1, 2, 3, right? So until here, these first two commands, or first three, do exactly what the PyTorch data loader does. So Hoopty-doo, I think, as I was just asked before, hey, why do I need to enhance or modify? Here we go, the answer. And this is just part of the answer. You'll see much more of the answer as we go through the rest of the walkthrough. The hooks that you can add is, for example, and you can specify an after iter, and this is a callback. So I would encourage you, if you're not familiar with the concept of callbacks, I provided some links and you can go through them and really understand that essentially it's a function that you call when you get to execute. You can specify the lambda set attribute function as a definition of after iter, so that after the iterations are complete, when the data loader runs, you then set the attribute of some set the value of the T3 attributes, or I should say the F attribute of T3 to be 2. So what we have done is specify an after iter callback, which will run at the end of each iteration. And here T3 is just some tensor, and it sends the F attribute of that tensor to the value 2. So you can see what he has done is specify DS1 as the data loader. He just converts, just to keep things interesting, it makes it a string, batch size of 4 again. After the iteration, meaning after this entire set of batches have been created and provided, if you will, by the data loader, you want this function to execute. So you check the test equal types. He wants to make sure that the type is strings, even though, and that's the reason he has converted it to a string, because you can see that he's testing that the type of DS1 returned is what each of these converted to strings. Notice that earlier these were tensors. So he converts it to a string here in the data loader. He wants to check that they've successfully been converted to strings and they are not just tensors. And then he also tests that the T3 tensor gets an F attribute with a value of 2. So this is an example of the type of customization that you can do with the data loader. That is, you can specify a callback, which is to run after all the iterations are complete, and do whatever you want to do at that point.
Sorry, I have a question. 2 questions actually. The T3, was it a predefined tensor or just got it now?
I don't really know. It could just be the third tensor, but it could also be a defined tensor value.
Oh, okay. Okay. The second, the test equal types, is it just checking that the output is string? What of the L's? Doesn't make sure that they are consistent, that both of them are type L.
No, I don't believe that it checks that both are L. I believe it checks that the type within the L is the same, but you can play with it to confirm that what I'm saying is true. I believe that it only checks the values returned from the L, not that it is an L.
Okay.
Because it's checking the type of DS1, which is these values of the lists that are returned. So I think that, and you'll have, you can look at the test equal type code, which we will much later on, but it's a good question. My understanding, and I haven't delved into that to confirm it, you can easily confirm it by looking at test equal type code. In fact, what does it say here?
Yeah, can you just run it, please?
Yeah, it says that A equals B. So, well, if A equal B, then A says L of DS1. So it would assume that you probably check that this is L and then test each of the individual values within it to be the same as what DS1 is as well.
If it's possible, can you please run it like just that DS1 and then test, then remove the L from one of the outputs and see if it will throw an error?
Yeah, that's possible. But the honest answer is don't know. If I were to guess, I would check that. I would say that it probably checks the values in DS1, the types of the values in DS1.
All right. Thanks.
One question, Srinivas. The after iter, does it run after each batch or after it goes through whole range here?
Good, excellent question. It runs after all the iterations. So it's not after batch, it's after iter. And so that's where the definition of the callbacks is something that, should get familiar with. But he talks about it in the walkthrough. After iter is after all iterations and before iter is before all iterations.
So I'm assuming after iter is a part of a data loader.
Yes. You'll see how it does that when we get into the code. We will get into the details of how it does that, and that's fascinating in its own accord.
Okay, so another confusion, I think this question was just asked. T3, is the T3 is the tensor, where did we define it? Like, is it part, I didn't see where we defined it.
Yeah, it's again, it's not, it's not material.
Sorry, we're defining it right there on the call in DS1 equal DS1 equal data loader. If you notice at the end of that command, it says set attribute T3F to 2. I believe that's where you are actually just defining it right there in the line, one line above of that test equal type.
Yeah.
Thing here. But he's asking where is T3 itself defined, and that's where in an earlier answer I'd said, it may be, and I haven't looked at that particular part, whether he defines it elsewhere or is it just that you just create a tensor called T3 and stick in an attribute F on it with a value 2. It's just an example illustration. Go ahead, somebody wants to say something.
Yeah, what I was trying to get into is like, this is what I'm assuming, that the T3 tensor or the set attributes of a tensor, which we are going to do whatever we are doing here, is a part of a first statement somehow. That's why we're having a callback where we have some processing and then call back to the same set of tensors.
Yeah, that's my guess of how you would actually end up using it, but this is where the real actual usage is much more intuitive to understand than when he's trying to explain with toy examples.
Yeah, makes sense. Thanks.
Right. So you'll see that when he actually uses it, it becomes kind of clear of how this gets used and where we would use it. This is just a toy example. He shows that, oh, you can do this and set some attribute on something after you have run all the iterations. That's it.
Okay, thanks.
So that gives you an example of something that, again, to your question earlier of what's the difference between and why does he want to screw around with the PyTorch data loader, this is just the beginning of the examples that he shows us all the flexibility and customizability of FastAI data loader compared to the traditional PyTorch data loader. This is just the beginning of what he reveals in the rest, right? So another example, so before the hooks that you can add, everything, even the PyTorch data loader could do. But this particular part, customization, is not something that a PyTorch data loader supports. The second thing he wants to illustrate is, we have so far passed in letters or numbers, but it's a collection, like a list or a range to the data loader. Instead, we can actually also supply a generator as the first element to our data loader. So again, if you're not familiar, and maybe many people are, but if you aren't, I'd encourage you to go. I think I provided the links again previously, either in the first or the second walkthrough. Generators in Python, essentially generators, iterators. There's no length to them. You just get the next value as you keep going through it. So you can see what he has done is created an IT, which basically stands for, and this iter function converts something into an iterator, into a Python iterator. So he takes a data loader, he maps no-op, which again, in FastAI Noop, he defines as a no-op. And so basically he maps a no-op into a range of 20, which means, you get from 0 to 19, but this is just mapping no function into range. So you essentially get 19 values, batch size of 4, you're specifying the number of workers as 1. The difference is you've converted it into a generator. And when it's a generator, then as I said, you can't get items from it like you would from a list or a set or a dictionary. You don't have a dunder get item for it. You just have a dunder iter. So each iteration will give you a set of values. And
so is this then 5 batches of size 4? Is that what this thing, an iterator that can go through 5 batches of size 4 each batch?
Yes, that's correct. Exactly, Joseph. So the IT is just the iterator, and the next of the iterator will give you the next batch. He's just taking 3 batches. So you can see the 3 batches, but if you wanted, as Joseph said, if you made this, I think 4, you would get the rest of it as well, 4 or 5, whatever it happens to be. But the point here is illustrating is you can provide a generator to the data loader and it'll work fine as well. Okay. Now with this, we'll see, we'll kind of use this as the entry point into our data loader code and figure out all the details of what is happening. But one thing I would illustrate right off the bat, if we go back to the data loader code here, as you can see, I have a lot of comments explaining. We'll get into each of these, but let's kind of stick with what does the iterator, dunder iter, which we just used, as you saw, because this dunder iter is what is used to return the 4 batches or 5 batches or 3 batches or whatever that we just looked at. Look at what it does. It first randomizes, but more importantly, it runs whatever is specified in the before iter code. So that means if you specify some code in before iter, and how you will do that, we'll learn later, just a little bit later. But you run the self.before iter. So before you run any of the iterations, you run the code in before iter, and you can see that at the very end, you run after iter. So you run before iter and after iter as kind of bracketing the iteration code, right? Before iter and after iter. So that's the explanation also to the earlier question of what do you do, or when does before iter and when does after iter run? So it runs before all the iterations and it runs after all the iterations. And then he cleans up a little bit afterwards, which will, you can figure it out, but that's kind of before iter and after iter, right? So now if you look at this code, you can see that B in loaders self.fakeL, this particular line of code in the loaders is kind of using the underscore fake loader, which is our way of backing into the PyTorch data loader code, right? So let's look at what happens when we say safe, or what is the self.fakeL. The self.fakeL is actually defined here in the init portion of the data loader code, which is the self.fakeL is underscore fake loader self pin memory da da da. And as he explains in the walkthrough video, PyTorch expects this particular class of fake loader to have certain values. And that's why he has to define the loaders. Remember, he uses the multi-processing and the single processing loaders. And he defines the self.fakeL to be an instance of the fake loader class. Now, this iterator of ours, which is the data loader iterator, as we come in, we do execute the before iteration and then call this particular self.fakeL, which is an instance of the fake loader class. And PyTorch expects this particular underscore fake loader object to exist, and it then calls that object's iter function. And if you look up above, he has defined the fake loader class or in FastAI. And here is where we begin to enter into what the actual data loader itself is doing. Okay, and if you look at the iter of the fake loader object, you can see that the first thing it does is it calls self.d.sample. And then after executing that code, it calls create batches. So let's look then at what sample does in our data loader class. So what sample does in our data loader class, you can see that there is the sample is it gets all the IDs. And what does the get IDs function do? It just gets a bunch of IDs for the items from the data set or from the generator. Remember that the FastAI data loader supports a generator as well as a data set. A data set is just something that has a length, as I've explained before, and has a collection of items and is indexable. So if it's indexable, then he uses, and this is a custom FastAI class that we'll learn the details of later, but here for our purposes, what we need to understand is the fact that this infinite class helps to create two types of infinite lists. One which creates a count, so it gives us lists of integers, so it gives us a count, and another which is used for infinite lists. And if we are using it for infinite lists, then it returns an infinite number of nuns. So the get IDS, which is used for sample, which is used by the sample, returns, if the index is true, then it returns an infinite count of integers. And if it's not true, if index is false, then it returns an infinite list of nuns. Okay, and we'll get into why the shuffling aspect in a little bit. But bottom line, IDX, it returns count if we have the index value set to true, otherwise returns nones. And then depending on what your n value is set, which is set in the very beginning here, if self.n is none, raise type error, and then batch size, then return self.none. So you can specify the batch size, but if batch size is not specified, data loader is clever enough to think of it as, oh, I'm not going to batch the data, and will show that in that case, it takes the entire data set to be a single batch, or there's no batch and it takes the entire data set. But bottom line in sample, what has happened as a result of getting into the get IDS is it returns all of the IDXs we need, that is all of the indexes. If shuffle is true, then it shuffles the indexes, so it shuffles the count, so we can get, create the random probability that we need. Typically, for example, for MNIST function, you don't want all of the images of 0, 1, 2, 3 to come in order. You want it to shuffle them so you learn better, and you get all of the samples. We will better understand this particular line, which is, it returns the batch B, but what it does there with respect to this last bit of code is something that we'll understand better as we get into the details. But think of it as returning B right now using the IDX. That's what the self.sample stuff does. And once that happens, that is, you got the samples, then going back to where we were in the object, remember we were in the iter part of the fake loader. So right here, we have now gotten hold of all the samples B. Then we go to executing the create batches code in the data loader. So back into the data loader code, we go to see what create batches does. And create batches, if it's an iterator, then it creates the .id. But bottom line, it goes through everything in the sampler. So that's what the SAMPS is that you pass into it. So it goes through all of the SAMPs, but how does it do that? Well, that happens in this next line of code. And let's ignore the first part for a minute because it just handles some special case. But what actually does the create batches code, what it does is it maps the do item function on all of the samples. Now, at this stage itself, I've taken you through, multiple methods and calls. So you'll be wondering, why go through all this complexity? And you'll see, again, it's the answer to what I was talking about earlier. Every one of these methods, such as create batches, do item, samples, every one of those methods can be customized or can be changed by you to do something different than what he does in the data loader code. So that provides the incredible flexibility that he actually wants any user of the library to have once you understand what the library does.
Just a quick question. I mean, like we are creating a batch here, and we are doing quite a bit of a processing. Why are we calling it as a fake loader?
Oh, that's just something that PyTorch expects, and I think he's just being consistent with what it expects that class to be with its values.
And the class name, I mean, like, is it a requirement from the PyTorch, as you said?
Yes.
But I saw the class is not inheriting anything from a PyTorch. It's independent class.
It's not inheriting from PyTorch, but I believe it interacts with the PyTorch data loader code, which expects that object, fake loader object, which is why you see in the init code, he specifies self.fakeL to be an object which of class underscore fake loader with particular values for these things. like pin memory, number of workers, timeout. So what he says in the video is PyTorch expects an object of maybe of type or an object of underscore fake loader with these values. So he has to create that class and shove those values into it, which is what he does. And we'll get into this a little bit later, but basically he does that. See, right here I've said PyTorch expects an object with this list with these expected values.
Mm-hmm.
And he sets that up right here.
Okay, thanks.
Okay, so back to create batches, which is where we were. So it maps the do item onto samples. Okay, and now let's see what do item does. And that's defined. Let's see, where did I miss it? It should be there. So there is do items, and see what do item does is it creates the item and then calls after item. So you grab all these samples that you want, create a single item from S, and then call after item. But let's again take it step by step. Let's look at what create item does. So create item returns the next, if it is an iterator. If it's an iterator, it returns the next value of the iterator. So for example, if it's a generator, it returns the next generator value, that is, whatever is returned by the generator. If on the other hand, you're using a data set, it's not a generator, then it just indexes into the data set and returns that value. So that's what create item does. And you will see in a minute if we do get to it this time, otherwise we'll go through it the next go around. Yusuf, are we supposed to end at 9:30, in which case I'll just end right after this, or are we supposed to go till 10? I'm fine.
Well, actually, I've tried to build in like 2 hours in between classes so that one class can go longer. So I would say like if you go till 9:45, that's comfortable. Everybody can get themselves regrouped, ready for the 10 o'clock class. So yeah, I think you can go for another.
I think it's it's a few more. I think I should be able to be done, and then there's a lot to digest, so I'll kind of repeat this last piece at the beginning of the next lecture before we get into examples. So
Great.
That'd be good. Yeah, I'll try and wrap up by 9:45. So we saw that create item creates the item, and then you run self dot after item, right? So those are the two things that we do. And remember, we were in create batches code when we got into this. So because we were right here and we wanted to see what do item does, and do item, what it does, or what it does was create the item and then run after item. And so that's happened successfully, and we have put the item in RES. Now look what the next two steps do. The next step is mapping do batch after you run Chunkify on the result. So what does Chunkify do on the result? So if you look at Chunkify, here is Chunkify, which returns B itself if somehow the self.pre-batched flag is set. If not, it returns the chunks. And if you look at the chunked function, which I've kind of captured the code and dumped it here, basically the chunked function, what it does, it grabs batch size values, uses the drop last, which we had set up as a flag, and returns the B accordingly, depending on whether it is an indexable function or it's just an iterator. So if you see chunked, you pass in the first, which can be an iterator, chunk size, which is actually the batch size, and then you say whether drop last is false or true. And then depending on whether it's an iterator or not, it does its chunking piece. And again, something that Jeremy points to, and again, maybe there are expert Python users who are very familiar with it, but I would strongly encourage you to look at the whole class of tools that are more like functional programming tools that are available in ITER tools. And I think it would be great if you actually look at it offline. I provided a link to ITER tools in the standard library. And what itertools.islice does is it actually slices the iterator to a particular size that you want. There's an example somewhere else too, but bottom line, the chunk returns, depending on whether it's an iterator or not, the appropriate value of B. That's what Chunkify does. Back again to create batches, that's this part, but then you run the do batch on what is returned from here, because that's what mapping of this function over the second function does. And the do batch is right here. And you'll see that does a whole sequence of things on what is returned from, or what you get as B. So what does it do? It runs everything that is in before batch, and then it runs the create batch, and then it runs the self.retain. Those are the three things it runs in sequence. And before batch is it just runs the before batch callback, which says that you execute whatever you have specified in before batch, and then create batch. That's actually the create batch function, and it runs this function, create batch, which uses FA collate and FA convert. And if self.prebatch is already set up as a flag, it runs these two functions on that, and we'll get into why it needs to run these. The FA stands for actually a FastAI version of collate and convert, which it runs on the return value B. And then once that's completed, then the do batch does self.retain, and that essentially is the function which retains the types. You can see that self.retain is defined here, which retains the types which are there in result, and it gives you the first value of B0 if B is a list, otherwise just returns B. And retain essentially is retaining the types, which is very important for FastAI, because you want to maintain the subclass in order to be able to encode and decode in transforms appropriately. So after all this, if you go back to the ITER code, after all this work is done, then you come and you say yield, which means you do this lazily after batch of B. So this is when you're actually yielding the batch, and that happens after you've run the after batch code. So you've gone through, multiple loops, multiple points that you can customize. And after you have returned the batch, you do the self.afterIter. So you can see that, there are multiple points that we have entered and exited. Every single point, for example, when we saw here, before batch, create batch, and then of course self.retain type just retains the type, but before batch and create batch, and then even before that we had other callbacks. The point of all this, and we'll see that in the examples that we'll get to in the next lecture, maybe we can even look at a quick example since we have about 5 or 6 minutes, but the point of all this is the ability to customize every single callback, right? And how do we do that? You look way up here, and he defines these underscore no-op methods. So all of these methods the WIF, before iter, after item, before batch, after iter, all of this are put in a list underscore loop methods. And any of these, or I should say each of these, can be customized by providing a function that you want to execute when you hit that callback. Okay, that's the beauty of this complicated code of a data loader compared, or FastAI data loader compared to a PyTorch data loader. So why go through all this trouble of customizing the dunder iter, using a fake data loader, customizing that, providing multiple entry and exit points, is to support all these different callbacks: before iter, before item, before batch, after batch, and so on. So very quick example that we can hopefully just provide for taste or teasing purposes, if you will, is let's look very quickly at what an example of customizing a callback or a method or a create item function does, and how it provides flexibility to us. Again, I'll ignore, and you can read at your leisure, what generators, iterators, and the stop iteration exception does. But bottom line, what he has done here is defined a random data loader inherited from the data loader. And we'll see a couple of different ways we can do this, but right now let's stick with the inheritance way of defining and using a data loader. So let's say ranDL is inherits from data loader, so it's a type of data loader. And we have created a custom version of create item. Unlike the create item in the actual data loader, if you see, is this function right there. Instead of that, we are replacing this function in the traditional or FastAI data loader with what we are defining here. And what we are defining here is a simple 2-line function which just says get a random value. If the random value is less than 0.95, stop. If it's not, keep going. So if I execute that code, let's see with this time, oops, data set. So I need to execute the letters, which I guess I thought I did, but okay, I think I'm missing the definition of something, but I'll take it up from this point. But in the interest of time, I'll stop here. But there's something I'm not running in sequence properly. But bottom line, what it would do is then create item and provide the L of a data loader, and you'll see that it'll get a bunch of values that helps you illustrate, or helps to illustrate for us, all of the things that a customized create item function does. I think I'm screwing up something in not running it in sequence. Maybe I'm not running the data set. Let me get one more shot. Let's see whether let's jump, it's not needed. Yeah, there we go. Okay, so what it has done is run a custom data loader with a custom create item function, which says, I'm going to create a random value R, and if the value is less than 0.95, then stop. Or sorry, if the value is less than 0.95, then continue, and if it's greater, then stop. So as you can see, all these values are less than 0.95, and then it has hit a random value which is greater than 0.95, so it stops. And now you can just create a set of DS of 4 and map into the length. So it just creates the length of it. Now, again, drop last equals true. That doesn't tell us too much, but it just again creates is an illustration of what you can do with drop last. The bottom line, what it tries to illustrate here is you can create your own version of create item, your own version of every method in the data loader class. Create item, do batch, do item, any of these you can customize. And that's the beauty. And how that customization is done and what are its various applications is something that we'll look at in the next lecture or the next part of this walkthrough.
Just to add, Srinivas, I think the point that he mentions there with the Randial example is that you're inheriting from data loaders. Whereas the whole idea of having callbacks is you don't have to do inheritance. You can just pass it in along.
Yes, and that's in fact what I'll start with. You can see that illustrated in the cell below that, which is alternate way to create Randial.
Yeah, cool.
And that requires some level of support in the data loader class, and how he supports that in the data loader class. By supports that, I mean, you can just define a function and pass it in to create item as is shown in this particular example that I'm highlighting here, that Raquel is calling attention to. And that is something even easier to do than having to inherit from the data loader and create a new data loader. So you need not even create a new data loader. You can just define a new method that you want to replace the create item method in the FastAI data loader, and you can do that. You cannot, for example, do this in the PyTorch data loader, thereby giving you, again, very easy way to replace methods in the data loader of FastAI with your own custom defined methods. And how he supports that and the details of that we'll get into in the remaining part of this walkthrough. Questions? That's been quite a walk through fairly complicated code. As he said, it's kind of like almost at the, you're deep in the bowels of FastAI and its data loader. So it's quite complex. And so if it takes you 2 or 3 times, it's taken me multiple walks through this code to get an idea of even what all it does and how it winds its way through various callbacks. So don't be frustrated if you don't get all of it in one go. It's almost too much to absorb at once. There's a tremendous amount coming at.
Thank you, Sriram. That was really helpful.
Yeah, thanks, Srinivas. That was great.
Sorry, Srinivas.
Thank you. We'll start with this, I'll do a very quick recap of the winding path we take through the data loader to get to where we want to get to, and then we'll spend most of our time looking at examples of uses and the flexibility it provides.
So this is this will be we'll still be working with video 3 then for next time?
Yes.
Okay.
Most of the time we'll still stick with O2 data load, and the very end, he takes us back to O3 data core to illustrate, now that we understand data loader and data loaders, what does a transform data loader do and how is that different? And what are some of its nuances?
Okay.
Sorry, there was some other question.
No, it was exactly the same question. Thank you.
Yeah, so this is, we started in O3. That's just because of the data loaders class, which is just a wrapper around this class, because it just gives the ability to create multiple data loaders, of which train is the default one. And this is the underlying code of the data loader, which actually is a modification of the Python data loader, and provides you with all the flexibility that a FastAI data loader has. And then at the very end, probably the last few minutes, we go back to O3 to understand the transform data loader better. But most of the rest of it we'll spend in O2 data load.
Okay, well, let's end here, and some of us will reconvene in a few minutes for the hands-on ML, and if not, we'll see you next week.